So, this is I believe, the last dot point in this topic for the syllabus. So, the sums of arithmetic sequences are an application of arithmetic sequences. And this is the formula here that we need to use. So, essentially, the sum of an arithmetic sequence tells us the sum of all of the terms in that sequence. So whereas the formulas that we were working with before told us the value of a specific term, the sum of an arithmetic sequence tells us the sum of all of the terms up to a certain point. So this is really important for questions where we're asking, like how much of something has somebody accumulated? Maybe if an apple tree grows 3 new apples every day, I'm not sure how specifically accurate that is. I don't know anything about apple trees. But say an apple tree grows 3 new apples every day, and assuming that no apples drop off the tree, we would be able to find the amount of apples on the tree, say, at a certain period, right? But we'd also be able to find maybe the sum of the apples that have been grown over a period of time. Probably a better example of this would even be if you like earn a certain amount of money every year, and the amount of money that you increases every year, like what we had with the example before, you're going to be accumulating that money over a certain number of years. So while we'd be able to use the general definition of an arithmetic sequence to find how much money you make in a particular year, we could also use the sum of an arithmetic sequence formula to tell us how much you've actually saved over those years, or like the total amount that you've earned over those years. Maybe even another example would be if you receive or you produce a certain amount of product in a factory every day, but as time goes on, you become a better worker, so with every day you increase your production by like one more product. So you're making chairs, you make one more chair every day. Would be able to use the general definition of the arithmetic sequence to tell us how many chairs you're capable of making in a single day. At a particular time, after working at the factory for 30 years, how many chairs can you make in one day? However, the sum of the arithmetic sequence would be able to tell us how many chairs you've made in total over that whole 30 days. Okay. So as I said before, this is the formula that we're using for the sum of an arithmetic sequence. What it basically tells us is the sum up to a certain term n. So the sum of the first n terms. There's two kind of parts to the equation that we're given here, which can look confusing at first, but I'll explain where they come from. So, as you can see here, the difference between these two equations is in the brackets. So they both have n on 2 out the front, but in the brackets they're slightly different. So basically, this term, this first part of the equation, sorry, assumes that you don't know what Tn is, but that you know what n and d are. However, in this part, it assumes that you do know what Tn is. So how we get these formulas is we just add the general definition of the arithmetic sequence. So starting from this formula here, if we substitute in for Tn our general term, which is going to be T1 plus D and take 1, if we substitute that in, we're going to be adding T1 plus D and take 1. So simplifying this, our two like terms are going to be T1. So it's going to give us 2T1 plus and take 1 D. And as you can see here, this is the first part of our equation here. So my point here is that, listen, you use this first part if you don't know what Tn is, and you use the second part if you know what Tn is, but it ultimately doesn't really matter that much which one you use, so long as you understand, because you can use this second part of the formula and then use your general Tn definition of the arithmetic sequence just to find your Tn value separately. But yeah, just so that you guys understand that these actually are equal and where they come from. There is a proof for this, but we don't have time to go through it today, unfortunately. Okay, let's get into an example. So, what we have here is we need to find the 40th term, the sum of the first 40 terms, and the sum of the first 100 terms for the series below. So this is a similar question that we did earlier in the lecture. So we've actually already found the 40th term in that example before, because this is the same series. So what that means, because we already know Tn, we can use this shorter part of the equation here. If we hadn't already known Tn, we could have used that longer part of the sum equation, or we could have just found Tn separately, as I was saying before. We're going to sub in our n, which is going to be 40. So remember from our definition of the sum, if you are finding the sum for 40, or the sum up to the 40th term, our n is going to be 40, divided by 2, our first term, which is 6, plus our Tn, which gives us 9,600. But now we need to find the term for the sum of the first 100 terms. Now, we don't already know T100, which means we can use this longer equation. And we're going to sub in n equals 100, our first term 6, 12 is our difference, multiplied by 100, take 1, which gives us 60,000. Again, checking that this makes sense within the context of our sequence. Our sum of 100 terms is a lot larger than our sum of 40 terms, which makes sense. Getting back to the example that we were going over before as well. where in this section we need to find how much she actually earned over that period. So in the first part we found out what her salary was after 30 years. Now I need to find out how much she actually earned, kind of in accumulation. So we already know all these values. We know we want to find the sum of 30 because we want to find out like what's the sum of all of her salaries for those years, right? So we're going to use our shorter definition, plug in all of our numbers, and this gives us a total earning of $2,452,500 over 30 years. So Amanda has a lot in the bank, apparently. Okay, getting on to another question. So, we need to find the general term for the sequence being summed if the formula for the sum of the first n terms of this sequence is given by the sum of n equals n squared